All right, we're going to conduct a measurement system analysis on attributes. And the file that has the data in it is msastudies.mpj. And if you look in the worksheet folder, you can see that there's three worksheets in here. So the one we're going to be focusing on is the smear test. And so what the team was attempting to do, they were making glazes that were being put onto plastic parts, and then it would make these plastic parts look like wood. So they had a color of fruit wood, they had a color of cherry, and they had a color of maple. And then there were samples that were made up of these three different colors, which were, and those three colors are very different. And then there were samples made up of what was considered to be acceptable and what was considered to be not acceptable from a color standard standpoint. And then what we were going to present to the operators were these samples, and then they would say yes it matches or no it doesn't match. And so each operator had two different tests where they had a chance to go through all the samples. There were 30 total samples, okay, of the three different colors, 10 of each. And we had 10 different operators, each doing 2 assessments. And one of the things that you do in Minitab is to give a column for the operators that are in the same order of the columns that you had with all the data in it. And notice that there's an Andy and an Andy underscore 1, and that's because in this object-oriented database we cannot have a column in our worksheets that have the same names. All right, because that would be a field name. Each field name has to be different. All right, so that was the setup, and this is actually, this particular set of data, this is after they've tried to improve this measurement system a couple of times. And in another factory, they had, we'd used a thing called a dip test, where we were dipping a particular type of paper into a stain and then using that dip test as a way to validate that yes, the color was going to match the customer requirement. This was a smear test because we had a glaze, and the glaze sits on top of the plastic and it doesn't get absorbed. So we're trying to come up with what is going to be this good way that we can validate the color so that we're getting the right color that matches the customer requirement onto the parts. So let's see how this turned out. All right, so we got everybody together. We have our samples. We have our standard answers of either yes, it matches the sample, or it doesn't. And then we put all of our personnel through this to find out, is this measurement system going to be adequate from an attribute assessment standpoint? All right, so with all that explained, we're going to go to Stat, Quality Tools, and we're going to select the Attribute Agreement Analysis. All right, and so what we have done is we have actually, I'll delete this, but what we've done is actually we've highlighted all of the appraisers. Hold down the Shift key. Now you do have to use the Select button to put them in here. Double-clicking would only send one over. So we've got all of the operators. All right, there's 10 appraisers. There's 2 trials per each. The appraiser names has its own column, all appraisers. The known standard is in C1, the known standard. And from an option standpoint, we're not going to do any of that. From a graph standpoint, we want trials per appraiser. Okay, trials per appraiser and known standard. Display the figures on one graph. We want to do that. From a results standpoint, we want percentage of assessment agreement within and between the appraisers. All right, so we have that all set up. Let's go ahead and take a look at the result. All right, so here is the graph that shows the within appraisers. Now, what within appraisers means is that did the appraiser agree with themselves both times that they did this assessment? Or it could be 3 times if you had 3 assessments. All right, so we see, what's the percentage of agreement that they had across all 30 samples when they looked at them 2 times. And you can see that Kathy and Tammy were very, very high, and that was at 96%, and this was at 100%. And we see Valerie and Andy, not so good. Now, if we take a look at our 2 best, Kathy and Tammy, when we went over to see how well did they agree with the known standard, and we see that Becky was up here at about 93%, and Tammy was at 90%, and Valerie and Andy were really pretty poor. So they couldn't agree with themselves, and they couldn't agree with the known standard. So from this, we can conclude that Valerie and Andy probably should not be inspectors because it's just not in their DNA. All right, and the other thing that we can conclude looking at the appraiser versus the standard is this method just really isn't working. Even though we got a couple of the inspectors able to agree with themselves pretty consistently, the majority of them couldn't, and nobody could really consistently agree with the standard. So there's got to be a different method. This is significantly better than when we first started, but it's still not good enough, because we would like to see all the appraisers in the 95 to 100% range in the ability to agree with themselves. And agreeing with the standard should be in the 95 to 100% range as well. All right, and we'd love to see everybody at 100% in both areas. And if we take a look at the session window and we just scroll up a little bit, all right, and we can just see here's the percentage of agreement, of disagreement. What was the percentages of actually, agreeing with the standard, and what were the percentages of agreeing with themselves. And for the most part, they were in the 80 to 100% range, some not so good. And then we just didn't have a good enough agreement with the standard. So what we conclude from this is that this measurement system from an attribute assessment standpoint is just not good enough. So we got to go back to the drawing board and come up with a better method, and that's how you would conduct an attribute assessment agreement using Minitab.